Okay, so there's some changes to this from the last time I wrote this. 2018, which is a version I think most of us are on, now only comes with Visual Studio. You don't have a choice between Visual Studio and MonoDevelop. You also don't have a choice any longer between C# or JavaScript, which was really annoying because I put in my syllabus that you could do your assignments in C# or JavaScript, and now JavaScript's no longer supported by Unity. In fact, they're going through and they're removing all the JavaScript from all of their assets on the asset store. Wow. It's going completely .NET, completely Visual Studio. Even if you're working on a Mac, you have to start adapting Windows sort of themes. So Unity started off originally as a Mac product. It only ran on Apples. Right. MonoDevelop is an Apple development environment, and a lot of times you're going to see a warning message come up about inconsistent line endings in some of your code. You're just going to see this message whether you open up Visual Studio or sometimes you come over here to. I bet if I look in here, I bet I find it where it's talking about inconsistent line endings. But those inconsistent line endings, they go all the way back to Unity being an Apple thing. Apple is based on Unix, right? So it's got one type of invisible character for a line return. Windows uses something different for a carriage fee, and that's what it's complaining about, is this invisible character that you can't see and doesn't really affect anything. But okay, so when you look at a monobehavior class, let's actually open up a piece of code here, and there happens to have one here. We'll look at this spin free script. So anytime in my project, if I see a component and it's got this little C# emblem next to it, that tells me that it's probably a script that I can open and edit. And so I can click on that little gear and go down to edit script, and it's going to open up whichever script editor I have associated with it. And you should not be getting these error messages. It's only on this machine because stupid .NET installation doesn't want to. But once you get past those, it straightens out just nicely. Okay, so this is a script that I got with this prefab. Some interesting things. If I put this little tooltip directive in here, then it'll put a hint over that field in the editor. So there are several predefined methods that goes into a Unity behavior script. Anytime I see one that has this sort of where it says spin free : mono behavior, what that means is that this is a new class that's called spin free, and it's extended from mono behavior. So I'm taking the class mono behavior, I'm making a new class called spin free, and anything that I add to this spin free class gets added to the mono behavior class, or I'm overriding and replacing something that's in mono behavior. Well, mono behavior is a class that's built into Unity, and it has several predefined methods inside of it that you can call that would do things. In a regular mono behavior class, they're all empty. So if I see one that's called startup, then it only runs at startup. If I see one that's called on awake, it only runs once when the application comes up. I put a method in here called void update, and update gets called every single frame. So what Unity does, and this is where it really becomes an engine, you take this hierarchy of things over here, every one of these things is a game object. Unity goes to all the game objects and says, hey, game objects, if you got any components that are based on this mono behavior, have you got any of these behavior scripts? Yes, I do. So it goes into there, and it gets all of the methods for startup, so stacks them all together. It gets all of the methods for update, stacks them all together. And there's a bunch of other special ones. There's on trigger enter, on collision, late update, fixed update. There's like a dozen and a half different predefined scripts that get executed at specific times during that game loop. And a game loop is everything that it does in between frames. Oh, it's going to try and run at 60 frames a second. That's its target. That's its target frame rate, is 60 frames a second. Maybe it'll be able to do more. Maybe it'll be able to do less. If it's able to do more, I can always throttle it down to keep it at a fixed 60 if I have a need. Otherwise, it's just going to go like crazy. So the update method is going to get called an unnumber of times per second. If my frame rate is very low because I've done a lot of really stupid things with the geometry and the lights and I'm really dragging my application down, then frame rate's only going to get called a few times a second. If I don't have a whole lot of geometry and everything's really, really fast, then update's going to get called more than 60 times a second. There's another one called fixed update that if I want something to happen on a predefined regular interval, I can use that. It'll happen at the same interval every time. But update, for most intents and purposes, is everything we need. It's easy to it's a one-to-one relationship between frames in the game and the number of times that this thing gets called. That's pretty easy to wrap my head around. So, and then basically what's going on in this script is a little piece of code that makes the planet spin. And that's what's going on if I press play over here.
What does the void command do? I'm not familiar with it.
Okay, so void in C# is the return type. So basically what that means is that I want you to run and I'm not expecting any values back for anything.
Okay.
So like if I had float all right, so what this one does, this is a method called sum two nums. Takes two numbers, adds them together, right? I have two parameters. These are called parameters, and these are things that are going to be coming in. So anything that calls sum two nums, like say down here in my update, and go sum two nums. And every frame, for whatever reason, every frame this is going to it's going to run this method sum two nums. It's going to add these two numbers together, and it's going to return that into this number variable, right? And that's what this return does. So anything that's got a void does not have a return type. It just runs and it's done, and whatever it's done, it's done. But I can give something like, if I give it a type like a float or an integer or a string or something like that, then the return type has to agree with that keyword. So if I tell it, hey, this method is of type float, it better return a float. If I tell it it's of type integer, it better return an integer. Actually, don't need that. Don't need that. Okay, so you've got the startup happens at startup, update happens every frame. There's a bunch of them, but those are the two that you use most all the time. In fact, if I come over here, let's say I'm going to remove this spin component. Stop it! Oh, what's wrong with you? Remove the component, there it goes away. Now if I go to add component, I can start typing in the name of different components. Like I start typing in call for collider, and it gives me a list of all these different type of colliders. I type in one, I want to call it planet action. Okay, it doesn't recognize a planet action asset in my project, and it offers me, hey, here's a new script. You want to make a new script? Sure, I'll make a new script. We'll call it Planet Action, create and add. And it's actually going to create a script down here in my asset folders. Look down. Here's Planet Action. And then to edit the script, I can either double click on it here in the project, or I can go to the edit script function on the game object that it's associated with. And this is what you get when you create a new behavior. I get this class called Planet Action that's extended from mono behavior, and it gives me two methods that I can use. Here's my start method. I can put any code that I put in start is only going to happen once when it starts, and then any update, just like the other time, anything that I put in update is going to happen every frame. So this is another one. This is one that I wrote that is a lot like the other spin class, except it's pretty simple. I have a speed, and then every frame I rotate it by whatever that speed is. A lot of times you're going to see something called time.deltatime, and it might be useful to know what that is. Time is a class that I can use, so I could say, hey, time class, tell me the time now, or tell me the number of milliseconds since the application has started, or tell me, I don't know, again, all sorts of different things. One of those things that I can tell you is time.deltatime, which is the amount of time in milliseconds that have passed since the previous frame. So just like update is going to happen on an irregular frequency, time.deltatime is going to have a different, very, very small value every frame, because frames don't happen exactly on the same timing interval. So time.deltatime is always going to be a little bit different. It's however long it's been since the previous frame. When you see something multiplied by time.deltatime, like I've got this value of speed times time.deltatime, whatever this value that I'm multiplying times time.deltatime, it's going to take 1 second to reach it. So in this instance, I'm using speed as a value of 2. I'm rotating by speed, so speed is sort of degrees. Multiplying it times time.deltatime means that when this runs, it doesn't matter what platform I'm running it on, it's going to take 1 second for my thing to rotate 2 degrees. So it doesn't matter if it's 120 frames a second, doesn't matter if it's 15 frames a second, it's always going to take 1 second for it to rotate 2 degrees. Do you follow what I'm saying?
Now, how does it know it's a sphere then, that it's rotating and it's doing degrees as opposed to speed just being moving linearly?
Because I'm actually telling it to rotate.
Okay,
so
but
right.
It's that rotate, it's not line 6 defining it as the 2.0F.
Right.
It's that you're using that speed variable with the transform rotate, so it knows to use that 2
right.
as degrees.
Right. If I were doing scale or translate, then those values would be somewhat different. They'd be units instead of degrees. Also in Unity, as a matter of general convention, 1 unit is a meter. So if I draw a cube that is 1 by 1 by 1, and that's the default unit cube that I bring into Unity, it's going to appear to be 1 meter on a side if I look at it on any sort of realistic scale. So my lights, the strengths of the lights, the range of the lights, those are all assuming 1 meter per unit. The physics is based around 1 meter per unit. So it's actually got a gravitational coefficient. It's 9 point something meters and some change. That's the gravitational acceleration at 1 meter per unit. And as long as you're comfortable with that, scale, everything's going to work out just fine in terms of terrain, in terms of shaders, material size, effect size. As long as everything stays within that framework of 1 meter per unit, everything's going to work out just fine. Where it gets screwy is where we try to make an environment that's very scaled up. Like I'm working on a project with Bill Gorska from art, Matt Julius from biology, where we're going through a, maybe it's a 1 or 2 meter patch of riverbed, but the scale is so small that, you know, blades of grass are the size of trees, and we've got tiny little water bugs that, you know, at the scale that they're drawn, would be several of these tables in size. The fish swimming by would be the size of a Winnebago, because that's the scale that we're drawing everything at. So translation speed, the effects of the transforms, all of that stuff has to be modified, because now we're working at a much, everything's really bigger, but I guess that makes the scale smaller. It's hard for, anyway. But that's what time.deltatime is. You're going to see it a lot. You don't have to use it. If I don't use it, right, then it's going to be this speed every single frame. Every frame it's going to rotate 2 degrees. It's going to spin around completely out of control, but also it's going to spin faster or slower on different platforms, because my computer's got a lot more horsepower than my phone does. So my computer is going to be able to crank out more frames per second. So if I don't give it that time.deltatime, it's actually going to spin faster on my computer than it is on my phone. And if I've got 2 computers that have different capabilities, different graphics cards, different processors, then it's going to spin differently on the 2 platforms. Time.deltatime makes it spin the same speed no matter what I play it on. Because instead of saying rotate 2 degrees every frame, it's like, hey, over the course of the next second, however long that takes you, rotate 2 degrees. Okay, so what am I looking at here? So I've got this planet, and I've got this cube, and I've got this sphere left over from playing around this morning. I'm going to delete these things. So one of the concepts that I wanted to go over is the concept of nested transforms. If I've got say I've got a game object here, right, and it's got a transform. We'll call it at position 0, 0, 0. So it's actually at the origin. And then, just like I've got over here, where it says Earth high is, and if you look, it's just an empty game object. It's just got this one behavior attached to it, and then under it, I have an actual planet. And this actual planet is under the Earth high object. So Earth high, and then under it, I've got planet 128 tries is the name of that object. That first object on top is the parent. A game object attached under it in the hierarchy is going to be referred to as a child. And if I move the parent, the child is going to move with it. And if the child is located over here, and say it's got a transform of, we'll go out, 10 in the x, 0 in the y, -2 in the z, right? So it's over 10 units, it's down 2 units. That's not necessarily in world coordinates. That's relative to its parent. So if I, let's say right under this, I'm going to create a cube, right? And now no, I don't want a cube. Okay. I want a sphere. Give me a sphere. and we'll call this my moon. So you see my moon has a transform of -39 in the x0, in the y 40. I hate those round numbers. Oh, what is up with this? Oh, I know what's going on. There we go. That looks more like I was expecting it to do, because I was given the moon values and it wasn't moving anywhere, or it was moving where I wasn't expecting it to. Okay, so now 60 in the x, everything else is zeros. That's what I'm looking for. I said, oh, stupid. There we go. So my top game object is right at the origin. It's not rotated. The scale is fine. Under that, I have another game object. And I'm going to change this name to something. All right. And Earth surface is a child of Earth high. Moon is a child of Earth surface. So Earth high actually doesn't have anything associated with it aside from this game object. Now, if I rotate the top one, the moon rotates with it. So I see my angle changing here on my rotation transform from my top level, my top parent, right? But if I go down to Earth's surface under that, these values are unchanged. So it's still, as a child, it hasn't moved. Its rotation hasn't moved, its position hasn't moved. And if I go down here and I look at the moon, which is now way over here, its position hasn't changed. I gave it a position offset of 60 on the x, but that's relative to its parent. The parent moves, drags the child along with it. The child can move independently of the parent, but it moves relative to the parent. Does that make sense? You're sort of shaking your head, and you got this.
Oh no,
Okay.
I'm just nerding out. This sounds really cool.
Okay, it is really cool, and it simplifies a lot of things.
So relative to the parent, you could make it orbit.
Yeah, exactly. I can make it orbit, right? So because I'm using this parent-child relationship, there's really no difference between something spinning and something orbiting. If I'm spinning around a point at my center. If I'm orbiting, I'm spinning around a point that's over here.
Right.
But doing exactly the same thing. So I can make actually what I want is I don't want the moon to be a child of the Earth. I want it to be a sibling of the Earth. So you see I've moved it up, right? So I moved it up from being a child of the Earth's surface to now it's also a child of this main Earth thing. And really what I'm going to do is I'm going to create an empty game object. And that's also going to be at the center. Moon is going to become a child of that. So it's way out there. Moon pivot is what I want to add my orbit script to. So if we're going 360 degrees divided by 3 is 12. 1.23. Now that should work all right. Okay, so nothing is happening with my moon object. It's just a sphere out there that is the child of an empty object that has an orbit script attached to it. Earth glow doesn't really work for me, so I'm keeping it turned off. Earth's surface, I'm going to put an orbit script on it and make it spin at a different. And then Earth high, I'm going to take this script off. So now if I've got this set up right, I've got the parent that's not doing anything. I've got the Earth, which is going to rotate around that orbit. Then somewhere over here, the moon has a pivot point at the center of the Earth, but it's got an empty body out here. So the moon script is going to orbit around the center of the Earth. The Earth is also going to rotate around the center of the Earth. Now, if I wanted to, I could make the Earth a child of a big sun object and have the Earth orbit around the sun relative to the center of the sun. And I can stack these things up as however deep I wanted to. I could have things in orbit around the moon. I could have satellites in orbit around the Earth. And it's just, and now you start to see why they call this view the hierarchy, because you really will be working with a hierarchy of objects that are children of other objects that are doing things relative to each other, not necessarily relative to the space that they're in. So let's see if I got this set up right. So my Earth is spinning. If I go back to my scene, I can see that there's my moon spinning at a different rate, but they're both spinning around that point. But the moon is sort of way over here. And it's the same piece of code that's driving both of these. I'm just giving it different parameters for how fast I want it to spin.
Could you set up the camera on top of the Earth?
Yep.
Moving?
Yep. So right now my camera is just sort of here. This is just sort of where it happens to be. But I could definitely, let me go back to a perspective view. So I could set my camera up right here if I wanted to. If I go to main camera, game object, and then align with view, now my camera has moved to this point. And if I go over here and look at my game, that's the view that I'm looking at it from. So now if I wanted to give this thing a we got a 60-degree rotation there. Okay, so if I wanted to give this thing like a meaningful tilt. So now I've tilted the top level parent by 23 degrees. And if I've got this set up right, then the Earth should rotate around that 23 degree tilting the spindle, instead of spinning around like this, it should spin around its axis, even though that axis is rotated 23 degrees. And then the moon should follow like a 23-degree ecliptic plane as it rotates around. Or not. It's more like tumbling. All right, so maybe I've got something set up wrong.
Okay, that just messed with my head. Antarctica's just moving around.
That does explain the weather in Minnesota, though.
It does, a little bit more.
Yeah.
I think I can predict that one better. What does the dot up do?
So, all right, when tells it the axis that I want it to rotate around.
Okay.
So I can actually rotate around any arbitrary vector.
So up was Y though in this case, because that weirded me out the first time, because X
Yeah.
were the horizontal and Y was the vertical.
Yeah, it's a
So-
different sort of application. Some things, most real-time game engines have Y is up. Lots of different 3D applications have Y is up.
Is that from a look sensibility?
Yeah.
Can you
A lot of
change that?
CAD pack, no, not really.
No.
A lot of CAD packages have Z up. Lots of different applications have Z up, and to my mind, it sort of makes sense that Z is up. Once you get used to Y being up, though, it's just, the math is the same. It's just what do we call those variables?
Right.
The only thing that's different. Okay. Oh man, you want to talk about hurting your brain? We got to talk about what's actually going on in that rotate command, because it expresses this rotation as three angles, three Euler angles, and a rotation around the X, a rotation around the Y, and rotation around the Z. That's not what's happening under the hood. That's not what's happening inside the engine. Unity works with quaternions. With Euler angles, I can reach a thing called Gimbal Lock. If the axis that my camera is looking down becomes parallel with some other axis, like if I start looking directly down or directly up my up axis, whether it's Y. Well, if I'm only using three angles to define a direction, that all of a sudden becomes meaningless, and up has no meaning, and you get locked in that position. I don't know if you've ever played like an old school first-person shooter. Descent used to be really bad with this, where you tilt down and all of a sudden, whoa, I'm just spinning wildly out of control and I can't pull out of it. That's called Gimbal Lock, and that's what happens when you only have an X, Y, and a Z rotation to describe your orientation. Now, it makes sense for our puny human brains to describe everything in terms of X, Y, and Z, X, Y, and Z, X, Y, and Z. Rotation really doesn't work with three variables. Quaternions avoid the Gimbal Lock, and they define both a direction in 3D space and a rotation around that direction. And they've got X, Y, Z, and W as values inside of that data structure that you can get. They're not angles. I'm not sure exactly what they are. They're imaginary numbers. It's a set of four different imaginary numbers that somehow point in a direction and an orientation around that direction that they're pointing. So that's what Unity uses under the hood. That's what Unity is using in its physics engine. Every time it rotates something, it just gives you this nice representation. In fact, if I go over here and go to debug mode, now I see what the quaternion values are. So somehow a 60-degree rotation around the X gets turned into a 0.1193679 in the X and a 0.979924. Those numbers mean nothing to me, and quaternions are just don't even go there, right? So the point I'm trying to make is there's some things about the way Unity moves things around and the way it rotates some things. You just sort of have to take it. It's going to try and make it as easy for you as it can, but most people's brains cannot wrap themselves around what's going on with a quaternion, myself included. I've looked at the math, it's scary. It's got tentacles, and it's slimy, and...
You warned me and I looked anyway. Oh wait, this isn't that bad. It's not good.
It's not good, but I mean, it could be...
Quaternion multiplication, it's fine.
Can I use Unity to make a map?
To make a map? Sure.
And what is used to make Google
Somebody came up
Maps?
with this in 1843.
Well, Google Maps is built on JavaScript on top of its own sort of infrastructure. So they have their own way of representing imagery, their own way of representing geometry, and they're handling all of that internally. You can use Unity to build a mapping engine, but you have to give it that same sort of structure. How do I want to use these images? How do I want to use these graphics? That sort of stuff.
Oh, yeah.
So they're separating it like in one block, isn't it? And then using that the vector to define.
Oh, I know just enough of this to be
When I
dangerous.
was installing Unity, it asked me if I wanted to use it for transportation.
Right.
I know, like to make an app. I don't know, to make something for adult or
Oh, was it asking you what you were going to use it for?
Yeah.
Oh, yeah. I usually don't answer that.
How does that apply? How does Unity apply to cars?
I can use Unity to build any kind of real-time graphic. So one of the projects that I'm thinking about working on this summer is an augmented reality turn-by-turn application for first responders to guide them to the location of a scene, and then once they get on the scene, to guide them to points of interest around the scene, where are the defibrillators, where's the fire extinguishers, that sort of stuff.
Okay.
I'm going to build it in Unity.
Oh, wow. Okay.
So, I mean, any kind of application whatsoever. It doesn't have to be an intensive, real-time scientific
Oh, no, I know. It's kind of cool just to see
type of thing.
all these
And
things.
it doesn't have to be a game.
It doesn't have to be a game. Certainly does not have to be a game.
Okay.
That would make sense, right? Because it's
Oh,
like-
I was
it's like
thinking,
a
if
slowly-
I wanted to do like a home decoration
Right.
page, can I take
Yeah.
a photo of my house, put it on Unity, and try and see how I can play with images?
Mm-hmm.
I can?
It's a little more work to it than just that, but yeah. Yeah, there's a little more work to it than just that.
Okay.
Imagine if
I'll try
contributions.
and do that.
And this is really good.